This is Puya. So in this video, I wanna review the concept of inheritance in C++. The focus would be on C++ programming, but the concept of inheritance can be used in any object-oriented programming language. So let's look at an example. I took this example from lectures from IIT University. So this example shows that like a bank account example. So like you can have like a bank account, but let's say that you can have different kinds of bank account. Let's assume that you can have a savings bank account, you can have like a deposit bank account, or you can have a checking bank account, right? So, and like for savings bank account, you might have like different subcategories, such as for like a minor, somebody who's less than 18 years old, younger than 18 years old, or like an adult. For checking account, it can be for commercial purposes or non-commercial purposes. So we have a hierarchy, right? So we have different categories. If we want to define a hierarchy of classes for representing bank account information, so for a base account, so like for any bank account, you might need an ID, your balance, the name of the account holder. But in subcategories, you might have additional member variables, um, uh, additional member variables. So like here, like you have like age and ATM number, for example, or for the checking account, you might have the overdraft amount, for like depositing, like the duration and the principal balance. So you might have like you have a base account that all of these bank accounts would have ID, balance, and name, right? But the savings bank account, in addition to the ID, balance, and name, would have age and ATM number. So the deposit would have, in addition to ID, balance, and name attributes, it would have duration and principal balance. Okay, so how do we like, and this can go on, right? Like other subcategories. So for a minor, you might have, in addition to ID, balance, name, age, and ATM number, you might have the guardian name. For the commercial, in addition to ID, balance, name, amount, overdraft, you might have the company name, okay, and the registration number. So we want to define a hierarchy of classes for representing bank account information. One quick note here, so that in the examples that you see, I used member variables as public. I define them as public, or like they're defined as public. This is not recommended, right? You remember that we usually want to have attributes or member variables as private, and methods or member functions as public, right? But here, because I just wanted to explain the concept of inheritance, I used everything as public for simplicity. Do not do this in your programming or in the exam. Okay, so this is like only for educational purposes. So one way of doing it, one way of defining the savings and checking or current account, so that it would have both, it would have all the ID, balance, and name member variables of the base, would be having a member variable of type base in the savings or checking class. Okay, this is not inheritance. This is called compositional way. Okay, so in that case, then like any object of class savings would have a member variable of class base, which itself would have ID, balance, and name. In addition to that, it would have age and ATM number. The same thing for class of current or checking. Any object of class current or checking would have a member variable of type base, which itself have ID, balance, and name member variables. Okay, so you see that like if we define the classes like this, first of all we have to define an additional member variable for each of these subclasses. And also, like when we want to access member variables from base, we have to use multiple dots, okay, multiple dot operators. But the inheritance way, right, so this is what we want to focus on. So inheritance way provides an approach for us so that we define a class that inherits everything from the superclass or the base class. So how do we define it? So when we define the class, we have a colon operator. Then here I'm gonna explain like what this public means later. Okay, so like this is called access mode, inheritance mode, right? So here the inheritance mode, for simplicity I chose it as public. I'm gonna explain what this means later. Okay, so here it means that class of savings is inherited from class base. It means that it has everything from class base. In addition to that, it would have extra member variables age and ATM. Same thing for class current or class checking. It's also inherited from class base. It means that all these member variables, even if it has member functions, all of them are going to be inherited. So this class would have all of these member variables. And you can access, if you have an object of class savings, you can access ID, balance, and name the same way that you access age and ATM. Similarly, for like if you have an object of class current or checking, you can access ID, balance, and name similar to the way you access amount and overdraft. So we don't have any additional member variable, right? And if we want to access member variables that are inherited or member functions that are inherited, we do it as if they're defined here. So this avoids duplication. We don't need to redefine everything in the class savings. We just inherit the class savings from class base. Okay, that's what inheritance means. Like inheritance is basically getting something from your ancestors, right? Like so for example, like I have my parents both have black hair. I inherited black hair from my parents, right? So this is an attribute that I inherited from my parents. So here this is the same case. Like this class savings is inheriting ID, balance, and name from class base. There are some terminologies that I want to tell you about. So this class is called superclass, and this one is called subclass. Superclass and subclass. Or we call this one parent, this one child. Parent, child. This one is also parent, this one is child. Or another terminology is base class, as it's shown here. Base class, derived class. So it means that this class has been derived from it. So these three different terminologies like are used in computer science programming like all the time. So like you have to be familiar with them. If you talk about superclass, base class, or parent class, we're talking about this one. If you talk about subclass, child, or derived class, we're talking about this one. So this is the concept of inheritance, right? It's much easier than the compositional way. Like it also like gives us more functionality. A derived class automatically has all the member variables and functions of the base class, can also have additional member variables or member functions, right? This derived class is the child of the base or parent class. This is basically what's happening here. So class base, class savings, right? So this is what's happening here. One thing that I want to mention later, maybe I can mention it now, but I'm going to emphasize on it later. Well, this is not inheritance, right? We could do also, like, we could have this similarly using friend classes, but this is not inheritance. Inheritance is a more efficient algorithm, or sorry, like a more efficient method to basically derive subclasses from the base class, instead of just like having a friend class or having an object of the base class in the child classes. So this basically shows how inheritance works. So this is the base class. These are derived classes from them. So all of these 3 subclasses would inherit ID, balance, and name from the base class. Okay, now this one itself, class savings itself, has 2 children, or has 2 subclasses. 2 subclasses are derived from class savings. So this one, class minor, it would have ID, balance, name, age, and ATM. In addition to that, it would also have guardian name. This one, the class non-commercial, it would have ID, balance, name, amount, overdraft. In addition to that, it would have work domain. Okay, so as you can see here, the class base would be the smallest one, right? If we know, like, if we look at the member variables here, like, we don't have any member functions, but if you look at the member variables, class base only has 3 member variables, right? Class savings would have everything that class base has. In addition to that, it would have age and ATM. So here, like you can think of, like, the child class would be always bigger, or like if you don't have any member variable, the same size, but it would be just like, it can't be smaller than the base class. It would have additional member variables, so it would be bigger than the parent class. Here, this one is like a grandchild, right? So this one would have everything that the savings has, would have everything that the base has. In addition to that, it has the guardian name. So remember this picture here, right? So this is like a very informative picture that shows that, okay, the base class is always smaller than the savings class, a smaller or equal size. And then, like, everything that's derived from savings, it would have everything that savings has. In addition to that, it has additional member variables and functions. So this is how the hierarchy works. One thing that I wanted to mention here is that there are no relationship between these children, right? They both inherit ID, balance, and name from the base, right? But age and ATM is specific to this one. Amount and overdraft is specific to this one. Duration and principal are specific to this class. Okay, so there's no relationship between the, like, siblings. You can think of them as siblings, right? There's no relationship between them. This shows an example of the same classes: class base, class savings, class current or checking. They are inherited from class base in the public mode. Again, I'm gonna talk about this later. Okay, and so you can see that, like, we can just, like, have access to the member variables of S using the dot operator. Here I'm going to mention again this, that, like, here, like, everything is defined as public just for simplicity. We usually want to have member variables or attributes as private, not public. But here, because we just wanted to like show a simple example, like we're using them as a like the access mode is public. Okay, so the same thing for object C from class current. The same thing is happening here. Okay, this is an example I wanted to show you here. So we have class animal that can speak, and if it speaks, like I would see out grr. And then we have a subclass cat, which is derived from the superclass animal. This one, in addition to this member function speak, it would also have another member function called jump. Okay, so the same thing we talked about member variables, it applies to member functions as well. So this one actually has two member functions, one derived from class animal, one derived from one specific to class cat. And then we also have a class tiger derived from class cat. Class cat already has two member functions, speak and jump. Class tiger would have an additional excuse me, an additional member function called attack antelope, right? So here, if we define an object, instantiate an object of class animal, if say a.speak, it's going to print gr. If we have object of class cat, let's call it cat, cat.speak, it's going to print gr. And then cat.jump, it's going to print cat jumping. The same thing for tiger. So now tiger is an object of the subclass tiger. So this object can call the jump member function or speak member function or the attack antelope member function. Okay, so this shows that everything we talked about member variables, it's also true about member functions. Now so now I want to talk about this keyword that we put here. So this is called inheritance mode. Okay, so you guys are already familiar with two keywords, private and public. Private means class members declared as private can only be used by member functions and friends of the class. Okay, so they can be directly used by member functions and friend functions or friend classes of that class. Okay, you see, it didn't mention anything about the children of that class. Okay, didn't mention anything about the children of that class. So it means that, let me go back to this example. If this was private, ID, balance, and name would be private member variables of class base, right? They're only accessible by class base. Okay, so if you want to have access ID of S already has an ID, but this ID is inherited from class base. If this was private, S could not access it. That's why I defined it as public, so that we don't have to talk about it for in the beginning of the topic of inheritance. If this was private, this would have given us an error, because it would say that ID is not accessible by an object of class savings. If we wanted to have access to ID of S, we need to have getters and setters, okay, or accessors and mutators. Okay, so that's one thing I wanted to emphasize. So private is always private, right? Even for the children. Okay, if a member variable or function is public, class members declared as public can be used by any function or in any object. Protected, it's like it's something that's only specific to inheritance. That's why, like, if you are seeing the topic of inheritance for the first time, this is the first time you see protected keyword. Class members declared as protected can be used by member functions and friends of that class. Additionally, they can be used by classes derived from that class. Okay, so what it means here in the same example, if this is public, S can access ID. If it's private, it cannot access ID. If it's protected, S can access ID because S is an object of class savings, which is derived from class base. Okay, so this basically summarizes everything that I wanted to mention here. Okay, but I haven't talked about the inheritance mode, which is this one yet, right? This table only talks about the private, protected, and public keywords that we put inside the base class. Okay, always remember that private is always private. A member variable or function that's private in the parent class is not accessible to the child class, right? I always use this example that, like, let's assume that your father, like, has a car, and like the car key is private, so, like, you don't have access to it. If you want to have access to it, you have to use a getter and setter. You have to go through the base class. You have to ask your father, can I borrow the car key, right? So the parent class member functions must be used to access. Member functions here means setters or getters. The parent class member functions must be used to access the private members of the parent. Protected members of a class appear to be private outside the class, but are accessible by derived classes. So protected, it means it's the same as private, except it's available to the derived class object. Okay, so that's the only difference between protected and private, right? For everything else, it's going to be private, but it's accessible for the derived classes. Using protected members of a class is a convenience way to facilitate writing the code of derived classes. So here, like in that case, we don't need to go through the base class getters and setters, right, to have access to protected member variables. Protected members are not necessary. Derived classes can use the public method of their ancestor classes to access private members. So you don't have to have protected, like you can use private and public. And then if the member variables of the base class are private, then if you want to have access to them using the derived class, you have to go through the member functions of the base class, which are the getters and setters. Some programmers, they consider protected as a bad style, right? So they just like use private and public. One other thing that I wanted to mention here, if the base class has a friend function, that friendship is not going to be inherited by the subclasses, by the children classes, right? So let's say that, like, if your father has a friend, he's not going to be your friend, right? Friendship is not inherited, right? So this is the concept of, so if this class had a friend function, it's not going to be a friend for the class cat. That's what I meant by friendship is not inherited. Okay, so now we want to now talk about inheritance mode, access control in derived classes. Two factors controls which members of a base class are accessible in a derived class. These same factors control access to the inherited members in the derived classes. So, like, let me explain this one. Let me explain this one clearly. So here, using this example, we say that, like, let's say that this member variables are public. They're public for the base class. Okay, they're public for the base class. It means that they can be used like objects of class base, like member variables can be accessed anywhere. Now, where these are gonna be inherited by class savings, so this class savings would also have these three member variables. But we wanna know if those member variables for class savings, are they gonna be also public for class savings? Because they were public for class base, are they going to be public for class savings as well? It depends on two things. It depends on their access mode in the parent class, also depends on the inheritance mode, inheritance access mode. Okay, so if we want to know what are the access modes of these inherited member variables for class savings, we have to see two factors. We have to see their access mode in the base class. We also have to look at the inheritance mode. So let's look at this example. So like this is whether the derived class declares the base class using the public access specifier in the class head, right? Or public or protected or private. What the access to the member is in the base case. These are the two factors that we have to consider. Okay. So if the member variables in the base class are private, if the member variables in the base class are private, they're also going to be private in the subclass, right? It doesn't matter what the inheritance mode is, right? If member variables are private, it doesn't matter what the inheritance mode is. Even if it's public, those member variables are going to be private, always inaccessible, regardless of the derivation access. If they are protected, okay, so you can think of these as two different filters, right? If they are protected, right, if the access mode is public, if the access mode is public here, if the derivation access mode is public, they're gonna remain protected, because public is less tight, or less, like as a filter, is less tight than protected, right? So this is more strict. Protected is more strict than public. So we have to look at like the strictest, like the most strict access mode, right? If the derivation is done using public derivation and the member variables or member functions are protected, they're going to be also protected in the derived class. If the derivation access is protected, protected and protected, like they are the same, so everything is also going to stay protected in the derived class. However, if the derivation access mode is private, so you have some protected member variables, you're deriving another class from the base class in the private access mode, which one is more strict, private or protected? Private. So all the members that are going to be inherited by the derived class, they're going to be private for the derived class. Okay, so let me go back here. I didn't talk about the public one. Let me talk about public one as well. If the member variables are public, okay, now the role of the inheritance mode, the derivation access mode, is very important. Okay, public is the least strict access mode, right? right? So if the derivation access mode is private, private is way more strict than public. It's like a much tighter filter than public. So everything it's gonna be inherited in the private mode. Similarly, protected is also um, sorry, it's more strict than public, right? So if the member variables or functions in the base class are public, but they are inherited using the protected derivation access mode, they are going to become protected. Because if you look at protected and public, which one is more strict? Protected. So everything becomes protected. If both of these factors are public, public and public, public, so everything would be also public for the derived class. So let me go back here. So here you see that this was public and this was public. So ID, balance, and name would also be public member variables for like are inherited as public member variables in the class savings. If this was private, then the ID, balance, and name would be also private in the class savings. Okay. Now, this one is very important. Let's look at this one. If this is public, if this one is let's say private, the derivation access mode is private. This code would work fine. Because this was public, it means that ID, balance, and name are accessible by S. So what does this private means? It means that ID, balance, and name are now private members of ID, balance, are private members of savings. So if we have another class derived from class savings, that class would not have access to ID, balance, and name because these are private members of class savings. So basically this two factors, this access mode in the base class and the inheritance derivation mode, it would basically show these member variables are going to be inherited in what access mode for the derived class. Let's look at an example here. So this basically shows like the two filters. There are two like filters. Like one is like what's the access mode in the base class. This is the first filter. The second filter, it's gonna be what's the derivation mode. Okay, so like you can think of it like as two filters. Like it has to go through both of them, right? So the most strict one would take over. Okay, like let's say private, if it's private, everything is going to be private. Doesn't matter like what the inheritance mode is. If it is public, if the inheritance mode is private, they're going to become private. If it's public, the inheritance mode is protected, they're going to become protected. Public and public are going to be public. Protected and private, they're going to become private. Protected and public, they're going to become protected. Protected and protected, they're going to become protected. Okay, so always the most strict access mode would take over. Okay, this shows the accessibility. Like public is the most accessible, private is the least accessible, protected is somewhere in between, right? Combination of both filters, this filter and this filter, determines accessibility and access control in the derived class. So these examples are good examples we can look at. So here class base has three member variables. One is private, one is public, one is protected. Okay, class D is derived from class B. It has M1, M2, M3. In addition to that, it has temp, right? If we instantiate an object of class if we instantiate an object of class D, we can't write d.m1. Why? Because this was private and it was inherited here as private. Okay, so it cannot be accessed here. D.m2, the same way. D.m2 is public, this is public, so that's fine. M3, this was protected, and this is public, so M3 is going to be inherited as protected. It cannot be accessed here, D.m3. I made a mistake here, so I should clarify this. If this was private, this would have given us an error because this is not a member function of this class. So we don't have access to ID here. Okay, so like I should clarify this. I made a mistake here. If this was protected, you would have a problem here. If this was protected or private. Because this main function is not a member function, so we don't have access to private members of S and C in a non-member function. Okay, so that's something I should clarify. Okay, so this is the reason like we don't have access to M3 here, because this is not a member function. The same thing for class B. So private and protected are not accessible, but public it is accessible. Another example here, class B, it also has a member function, public member function. Class D1 derived from class B. In addition to these three member variables and this member function, it also has x1, x2, x3 member variables and two member functions. Okay, so this member function has access to x1, x2, x3, right? But F2 doesn't have access to M1. Why? Because this is private, right? Private is always private, no matter what the inheritance mode is. This is going to be private, so we don't have access to M1. Although we have access to M2 and M3 because M2 is public and M3 is protected. It means that the children classes, they can have access to the protected members. If we instantiate an object of class D1, we can call D1.F1, that's fine. D1.F2, it's going to give us an error because of this line. D1.M1 is not okay because this is private. D1.M2, it is okay because this is public. Okay, right? D1.M3, it's not going to be okay. Why? Because it's protected. It's going to be protected here as well. So it means that it's not going to be accessible by a non-member function. It is accessible here by member functions of class D1, but it's not going to be accessible by a non-member function. Same thing, but this time the inheritance access mode is protected. So let's look at it. Again, this is going to give us an error, right? Because this is private, we can't have access to it. D2.H1, that's fine, right? So the member function would have access to private, public, protected members. D2.H2 is not okay because of this line. D2.M2, let's look at D2.M2. M2 is public here, right? But it is inherited in the protected mode. So it would become a protected member of D2, right? And protected members are only accessible with member functions of that class and member functions of the derived classes. This is not a member function, so we don't have access to M2. Finally, if this is private, again, this is okay. This is not okay. This is not okay. So all of these member variables will become private, right? We have access to we have access to M2 and M3 because they were like, if you want to look at this one, we don't even need to look at the access mode here, right? This was private, so we don't have access to it. This was public, we have access to it. This was protected, this is derived from class base, so we have access to it. If you're looking at this function, you only have to look at the access modes in the base class. But if we want to look at here, this is not a member function, we have to look at both access modes here and this one. So d3.g1, this is fine because it's public and all of these are okay, so that's fine. d3.g2 is not okay because of the first line. d3.m2 is not okay because m2 was public, but it's gonna become a private member of d3, right? So it's only accessible by the member functions or friend functions of this class, not even children of this class. Okay, so this is not a member function. Remember that main is not a member function of any class, so it doesn't have access to private or protected members. Okay, and this table summarizes it like if the base class members are private, protected, public. If you have public derivations, like everything is going to be private. If it's protected, becomes protected. If it's public and public, public. If the derivation is protected, this is going to be again private, not accessible. Protected and protected, protected. Protected and public, this is more strict, so it becomes protected. The private, everything becomes private. Okay, so that's how this is gonna work. Another example, you can go through these examples yourself. It's very similar to what we just did, so I'm not going to go through them. One concept I wanted to show is that look at these three classes. We have a class base. It has 3 member variables and a public member function called print info. Okay. This one is derived from class base. It has 2 additional members, but we have redefined the print info function in the class savings. Okay, so you can redefine a member function in the derived classes. So now if an object of class savings, let's look at this. If an object of class savings AC2 calls the print info, this AC3, so the colors are not correct. Sorry. If an object of class savings, which is AC2, if it calls the print info function, it would call this one. It wouldn't call this one, right? So you can think of this class as having 2 member functions. What are their names? It's print info and print info. Okay, one is derived from the base class, one is only defined in the subclass, derived class. Okay, if AC2, which is an object of class saving, calls print info, it's going to call this function. And you see that like here we did the same thing for class checking or class current. If AC3, which is an object of class current, calls print info, it's going to call this one. Although this class has 2 print info functions. Now you might ask, can AC2 call this one as well? Yes, it can. Can AC3 call this one as well? Yes, it can. How can it be done? So you can see that here in the print info function, I can just like say that I want to call the base print info, This is the scope resolution operator. This is the name of the class. So what's happening here, whenever AC2 calls print info, inside here AC2 is calling the print info of the base, then it's gonna print this information. The same thing here, AC3.printinfo, it's gonna go here. First, it's gonna call AC3, it's calling this one, right? So it can just call this one first. It would print all the information, ID and balance, and then it's gonna print here. I wanted to also mention that it is possible to also here write AC2 dot base : print info. That's possible as well. Then it would only call this one. Okay, so that's possible as well, because this is public and public, so that's fine. You can call it here. So this is called redefining, right? In terms of terminology, redefining and overloading are two different terms. Overloading is when two functions have different signatures, right? Either like their parameters, number of parameters, or their type is different. But here you see that both of these functions, they have the same signature, right? So it's called redefining. We have redefined that function in the derived class. Okay. You can also, like, I wanted to emphasize that structs can also be inherited exactly like classes, except that the default inheritance mode is public for structs. I didn't mention the default inheritance mode yet. For classes, if you don't specify the inheritance mode, by default it's going to be private. In object protected programming, one of the pillars of object-oriented programming is data hiding, right? So like by default, if you don't provide the inheritance access mode, it's going to be protected. But if you have structures, the default inheritance mode is going to be public for structures. This is what I was mentioning before. So you can see that here we have like a base class called sum class, and another class called sum derived class, which is derived from the base class, from the super class or the parent class, right? Both of them has print function, right? So we have redefined the print function for the derived class. This one actually has two print function, one derived from the base and one defined in the child class. If we instantiate an object C of this children class, this like subclass, C.print, it's gonna call this one. C.sum class : print, it's gonna call this one. Okay, so I wanted to show you that it's possible for the object, for the derived class object, to directly call this one as well. You have to use the scope resolution operator. Now, one important concept that we have to talk about is like how constructors are called when we have inheritance. In C++, whenever an object of a class is created, its constructor is called, but also its parent class constructor is called. Okay, so what does that mean? Right here, here, like, we are instantiating an object of class bar. Class bar is derived from class foo, right? So here, as soon as you remember, as soon as we instantiate an object, like, this is gonna call the constructor. Here, like, we don't have any parameters, so it's gonna call the default constructor, which we have here, right? It's gonna call this one, but it's not gonna enter the function, right? At this point, you remember that before we have a child, we have to have a parent, right? So at this point, it's gonna call the constructor for the super class or the parent class. It's gonna go here, finish this one. once it returns from this one, then it's gonna go here. So if you run this program, it would print foo's constructor, then bar's constructor. So always the parent's constructor are gonna be called first. Okay, so the object bar is constructed in two stages. First, the foo constructor is invoked, and then the bar constructor is invoked. The output of the above program will be to indicate the foo's constructor is called first, followed by bar's constructor. Why do we do this? There are a few reasons. First, each class should need to initialize things that belong to it, right? So like this constructor is usually used to initialize the member variables belonging to class foo, right? So like here, that's why like we call this one, not things that belong to other classes, right? So a child class should hand off the work of constructing the portion of it that belongs to the parent class. Secondly, the child class may depend on these fields when initializing its own fields, right? So we might have member variables or member functions inside this that would depend on some initializations that happens in the parent class constructor. Therefore, the constructor needs to be called before the parent constructor needs to be called before the child class's constructor runs. In addition, all of the objects that belong to the class should be initialized so that the constructor can use them if needs to. Okay, so what if you have a parent class that need to take, okay, so let's look at this one. Let's look at this one. So by default, the child class constructor would only call the default constructor from the parent class. Okay, so let's assume that here we didn't have a default constructor, instead we had a non-default constructor. If we do this, we're gonna get an error. Why? Because here it's gonna come here, it's gonna call the default constructor from the base class, right? And the C++ compiler is not gonna generate one because you already have a non-default constructor, right? You can't find it, so it would give you an error. But what if we wanna call the non-default constructor of the base class? We can do that in the initialization list of the constructor. So if you remember when we talked about constructor, we said that like we can have initialization list. So we can initialize variables, or we can call the constructor of the parent class in the initialization list. How do we do it? We just put a colon operator after the class constructor definition and class constructor header, and then here you see that this is not variable initialization. This is a function call. We are calling the constructor, the non-default constructor of the parent class. So here, if we want to call non-default constructor of the parent class, we have to do it in the initialization list. So here it would, if we didn't have this one, we would get an error, right? Because it would try to call the default constructor and you can't find it, it wouldn't generate it, so it would give us an error. But here, right, so as soon as you instantiate an object of class bar stool, like it would go here, it would call the non-default constructor of the base, it would print this message, it would return from it, then it would go inside the constructor of the derived class. Okay. Another example is shown here. Let me go through this one. So here we are calling the non-default constructor of the derived class. It's gonna go here. Okay. Actually, you can think of this as a default constructor because all the member variables, all the parameters, they have default values. But anyways, so here it's gonna go here, right? So the cost would be initialized as 0. Cost would be initialized as 1.3. It would take over, be overwritten. ID would become 5, and then it would call the base class constructor. Which constructor? The non-default constructor. It would go here. It would initialize ID as equal to 0. M underscore ID would be equal to 0 because this is 0, right? And then like there's nothing inside the function, so it would return. Once it returns, then it also initializes m underscore cost to whatever cost is, which is whatever we have here. Sorry, 1.3. 1.3, right? So like m under cost is going to be 1.3. So that's what's happening here. That's like basically I wanted to show you like this is a function call. So the control is gonna stop, like it's gonna go over here. It would finish this function. Then once it returns from it, then it will continue. This is a slide from IIT course on object-oriented programming. It's very useful. So you see that here we are instantiating an object of base class, right? So it would go here, it would print this one, initializes ID, initializes the balance, right? And then here AC1.printinfo, it's going to go here. Age and ATM becomes 20 and 240. We are instantiating an object of class savings, which is derived from class base. Okay, so age is 20, ATM is 40. It's gonna call the non-default constructor. So X becomes 20, Y becomes 240. The age member variable of AC2 becomes 20. The ATM member variable of AC2 becomes 240. Stops here. See, like it says 6A. 6A would stop here. It wouldn't enter this. It would jump to the base class. So this is 7. It would print default constructor base. The ID of AC2 becomes 0. Balance of AC2, which is like derived from the base class, becomes 0. Once this is finished, now it's going to enter the non-default constructor of class savings. It's going to print the derived constructor. This is going to be finished. This is done. AC2.printinfo, is it going to call this one or this one? It's going to call this one. We have redefined this function here, so it's going to call this one. Can AC2 call this one? Yes. If it says AC2 dot base colon print info, it would call this one. So you can think of constructor as something that's not inherited, right? It's going to be called by the constructor of the derived class. Okay, so you can think of it as something that's not inherited. So here, another example. This is a non-default constructor. It would go here. X becomes 20, Y becomes 240. Age becomes 20, ATM becomes 240. It's going to call the default constructor of the base class. We don't have one, and we have a non-default constructor, right? So the compiler is not going to generate the default constructor. So what's going to happen? We're going to have a compiler error, right? How do we solve this? By calling the non-default constructor of the base class explicitly in the initialization list. So you can follow these numbers again. So like this part is the same as before, but here when you instantiate AC2, ID is 10, age is 20, 240 is ATM. So it's going to go here, X, Y, Z are initialized. It gets to this point. Now we are calling the base class non-default constructor. So it jumps here. Initializes A as what is it, 10, and ID becomes 10, balance becomes 0, also prints this message. And then once this is finished, it initializes age as 20 and ATM as 240, and then it goes inside the derived classes constructor. This is another example. It's very similar to what we saw before. So like this one, like the only difference is that like we don't have any other member variable initialization inside the initialization list. Everything is happening inside the function. So a base class constructor is not inherited in a derived class. The base class constructor can be invoked by the constructor of the derived class. The constructor of a derived class begins by invoking the constructor of the base class in the initialization section. If a derived class constructor does not invoke a base class constructor explicitly, so if we don't do that explicitly in the initialization list ourselves, the base class default constructor will be used. Okay, so in this case, if we didn't have this one, we would get an error. If we didn't have this one and we didn't also have a non-default constructor for base, that would have been okay, because the compiler would generate a default constructor for the base class. But compiler would never generate a default constructor if you already have a non-default constructor. If class B is derived from class A and class C is derived from class B, so like you have like A, B, and C, then the constructor calls are going to go from top to the bottom. The constructor of A, B, and C. When an object of class C is created, the base class of A's constructor is firstly invoked, then B's constructor, then C's constructor. So you remember the constructor calls are always from top to the bottom, from grandparent to the grandchildren. I want you to analyze this code. So this is a good example that you can analyze the constructor calls using like 3 different classes. You see, like we have a superclass machine, vehicle is derived from class machine, and car is derived from class vehicle. So I want you to analyze this and see like what the output is, and then you can double check it yourself using a program. So remember, the order of the constructor calls is always from base to derived. Whether derived classes default or parameterized constructor is called, base classes default constructor is always called inside them. Okay, so it doesn't matter if you call the derived classes as if you're calling the derived classes non-default constructor right here. If you don't have this one, it's gonna call the default constructor of the base, unless you have an explicit non-default constructor call here. Like always, the default constructor from base would be called. And basically, this shows that like you have explicitly do that in the initialization list. We already talked about the reason for that, why base class constructor called inside the derived class. Another example to do more practice using constructor calls for base and derived classes. I'm not gonna do it for you. You can just like do it yourself. The same concept that we had for constructor is going to be applied for destructors. This time it's going to be in the opposite order. Destructor is also not inherited by a derived class. If there is a dynamic member variable, the derived class should define its own destructor. When the destructor for a derived class is called, the destructor for the base class is automatically called after that. Okay, so you remember that for constructor we said that the constructor of the base, then constructor of the child. Here we say the destructor of the child, then the destructor of the base. The derived class destructor needs only need to delete the dynamic variables added in the derived class and data that may point to. Okay, this is gonna be more explicit, if like more clear, if you use this example. So here, class base has a default constructor and a destructor. Class savings, which is derived from class base, it also has a constructor, default constructor, and a destructor. Once you instantiate an object of class savings, right, you remember it goes here, but it doesn't enter, right? So it goes inside the class base first. It would print constructor base. Once it returns from this one, it goes inside the derived class constructor. It would print constructor saving. Then you finish your program, you return. So this object has to be deallocated. So whenever an object gets out of the scope, like here, like at this point, when you return from the main function, the destructor is called. So at this point, it's going to call the destructor of the derived class. It's going to print destructor saving. At the end of this, automatically calls the base class destructor, right? And it's going to print destructor base. So like, I'm just going to review this part. Destructor B does not inherit A's destructor. After it exits, B's destructor will automatically call A's destructor. Had one good example here that we'll see later on. Okay, so when we want to talk about virtual destructors, we have a very good example that shows like how this one works. But one thing to remember here is that the constructors are called from top to the bottom, right? From superclass to subclass, from parent to child, from base to derived. But these structures are called from bottom to the top. So as soon as this goes out of a scope, right, it calls the destructor automatically. Once this one finishes, the destructor of the derived class automatically calls the destructor of the base class. I think it's a good point to stop here, and then I'm going to continue the rest of this lecture in another video. Thank you so much.